Alright, hello Mr. G. I am going to work on some of these problems and prove to you that I do know derivatives, and the test was a fluke. So, a particle which can move in negative meters, unimaginable speeds, and teleport, moves on the x-axis so that its position in meters at any time of t is greater than or equal to 0 is given by x of t equals e to the t times tangent of 2t. So first I'm going to find the velocity at t equals 0, so when the time is 0. So first of all I have to take this function and I have to find the velocity. So that is taking the derivative. So v to the t equals e to the t. Well, this is multiplication, and so this is going to be the power rule. And so I'm going to take the first, and e to the t is e to the derivative of e to the t is e to the t, which, yeah. And so now I have to take the derivative of this second. Well, first I keep the first variable, and then I take the derivative of the second. So tangent, the derivative of tangent is secant squared, and then the inside, and since there is a 2t on the inside, I have to use the chain rule, so that's times 2 because of that. And so the second half of the product rule is the second times the derivative of the first, which I already said e to the t is e to the t. The derivative of e to the t is e to the t. And so that is the derivative, the velocity of this particle. So now I have to set it equal to 0 to find what the velocity is at t equals 0. So e to the 0 times secant squared 2 times 0 times 2 plus tangent of 2 times 0 times e to the 0. So anything to the 0 power is 1. So 1 times secant of 0 equals 1 because of the unit circle. And so yeah, that equals 0, and so secant of 0 equals 1, and 1 squared is 1, so that's just 1 times 2 because of this right here, plus tangent of 0 because the 2 cancels out with the other 0. So tangent of 0 equals 0 times 1. So the velocity at 0 equals 1 times 1 times 2 equals 2, plus 0 times 1, which is 0. So 2 plus 0 equals 0. So since the position is given in meters and it is in seconds, so at velocity equals 0, when the time is 0, velocity equals 2 meters per second. So now I have to find how far the particle is from the starting point at t equals 0 to t equals 3. So I'm going to plug in 0 for the first original function, plug in 0 for t in the original function, and 3 for t in the original function, and I'm going to find the distance between those two numbers. So x of 0 equals e to the 0 times tangent of 2 times 0. So that equals 1 times, and I already said the tangent of 0 is 0, so 1 times 0, which equals 0. So at time 0, the position of the particle is 0 meters. Now I have to find the position at time equals 3. So e to the third times tangent of 2 times 3, which is 6. And I plug this into the calculator because I do not know what e to the third is. So x, the position at time equals 3 is negative 5.845 meters. And at the top I said that this particle could move in negative meters, so that's why it's in negative. So the distance from x of 0 to x of 3 is negative 5.845 meters, because that is the distance from those 2 points on the graph. So that's